Okay, in this presentation we are going to look at compound distributions and the central limit theorem and samples, statistics, the distribution of statistics. So, a device contains an electronic component which has a lifetime modeled by a distribution with a mean 3.6 hours and a standard deviation 2.6 hours. Okay, so the first thing to note, actually apart from those two details, is that you're not told if it's normal or not. Okay, so it doesn't, you're not given any indication there what to do. Okay, so we just know what the mean is and the standard deviation is, and for these type of questions actually that's what you need to know. Okay, on failure, a new component is automatically and instantaneously inserted as a replacement. Okay, so there's a big machine that uses up, in this question, 100 of these components one after the other, and when the machine runs out, when the components run out, a bit of a, let's say like a coffee machine or something like that. Now, consider the operation of the device with 100 such components used one after the other. Determine the approximate probability that the resulting total lifetime of the device will be greater than 400 hours. Okay, so essentially we're sort of setting up this random variable called t, which is the sum of the 100 durations for each component. Okay, so xi is the first, x1 is the lifetime of the first one, the first component, x2 is the lifetime of the second component, so on. Add up all of 100 of those, and we're not specifying it as a random variable called t. Now, t will have a mean of 360 hours and a standard deviation of 26 hours. Okay, so essentially what we're doing there is multiplying the mean and the standard deviation by the total number of items, in this case, like the total number of cases or the total number of outcomes from the X distribution that we're adding up. So essentially what we're going to do here is rely on the central limit theorem, which we will use in instances like these compound distributions. So we're looking at the mean of 100 items or the sum of 100 items and modeling that as a random variable. Okay, central limit theorem. Now, it's important to actually state that justify the central limit theorem a bit, because we're going to use a normal approximation for this. But what you have to do here is justify it and say that now you know what day it is. So justify it and state that it is normally distributed because x is large. In this case, n is large. N in this case is equal to 100. Okay, just spell it out. Okay, now after that, really that's actually where we need to be. Okay, so essentially what we have here is our the value, that the number that we're interested in, 400, and the mean, which is 360. Okay, and the standard deviation there is 26. So this is a straightforward z-score calculation essentially. Okay, so really you should be okay with this sort of stuff. You should have mastered this stuff, the normal distribution, before you got here. Okay, but essentially it works out, when you work through it, the z-score should be 1.54, or the z-score if you prefer, and then using whatever way you would sort of be familiar with, work it out, you should get an answer of 0.062. My pen jumped there, down here. That is the answer we're looking for. Okay, so that's it really. Central limit theorem and so on is the key thing there. Compound distributions. So we'll leave it there.